Hello and good day, viewers. For our fun chemistry experiment today, we will be looking into the concept of osmosis. To give you an overview of what we will be doing, we will be making a small rubber egg and a large one.
To start, we will be needing the following things: 3 containers, 2 eggs, water, sugar, and enough amount of vinegar to fill the container. Once we have all of that, we are now going to proceed in doing the actual experiment. The first step we need to do is place the 2 eggs in one container and then pour the vinegar into the same container until the eggs are completely soaked. Now, all we have to do is wait 2 to 3 days until the eggshells disappear. After waiting, let's now drain both the eggs and set them aside as we prepare the 2 new containers. For the first one, fill it with water, and the second one, fill with water-sugar solution. Now, let's note the mass of each egg. For the final step, let's put both eggs in separate containers. Then we will wait for up to 8 hours until we notice any changes.
So before we get on with the science behind the experiment, let us first try to learn and understand the concept of osmosis by the term itself. Osmosis is the movement of a solvent, such as water, through a semi-permeable membrane as of a living cell into a solution of higher solute concentration that tends to equalize the concentrations of solute on the 2 sides of the membrane. It was as if the solutions were driven to attain equal concentrations. There are 3 types of osmotic solutions. First, isotonic, wherein the water moves in and out of the cell at an equal rate, meaning they have equal concentrations of solute both inside and outside the cell. Second, hypotonic, wherein the water moves into the cell, making the cell too big, meaning it is more concentrated inside than the outside. Third, hypertonic, wherein the water moves outside, making the cell shrink, meaning it is more concentrated outside than the inside.
So, what would be the science behind this? These are 2 eggs submerged in vinegar for 3 days. Soaking it in vinegar will de-shell them as vinegar is acidic, and we will put each egg in 2 different solutions. One in a hypotonic solution, just water, and in a hypertonic solution, sugar and water. As time goes by, we can notice that the egg in the hypotonic solution has become bigger and the egg in the hypertonic solution has become smaller than before. The egg in the hypotonic solution became bigger because there is more solute inside the egg than on the other side of the membrane, and the water outside the membrane went inside the egg because of osmosis. Recall that osmosis is the movement of solvent into the solution with a higher concentration of solute. On the other hand, the egg with a hypertonic solution has become smaller because the solvent inside the egg has gone outside because the solute concentration outside the membrane is higher. Now that we know what osmosis is, here are some real-life applications of this concept. The first example is when sick people are hospitalized and an IV drip is administered to the patient. The IV drip solution needs just enough tonicity for it to be effective. What will happen if the solution is hypertonic? Water will move out of the cells and therefore cause shrinking. Meanwhile, when the IV drip solution is hypotonic, water will rush into the cell, causing enlargement until the cells burst. This burst is called hemolysis. The second example is when plants use their roots to withdraw water from the ground. The hair cells of the roots have a more concentrated solution than the soil, therefore the water will move toward the hair cells. Through osmosis, fries can be made crispier and less soggy by soaking the potatoes in a hypertonic salt solution before frying.
And there's a minimum pressure that needs to be applied to a solution to prevent the inward flow of its pure solvent across the semi-permeable membrane called the osmotic pressure. It's represented by the formula pi is equals to I mRT, where I is the Van 't Hoff factor, m is the molarity, r is the ideal gas constant of 0.8206 liter atm over mole Kelvin, and T is the temperature in Kelvin. In our setup, we use 343 grams of sugar and 0.24 liters of solution. I is equal to 1 since sugar is a non-electrolyte. T is equal to 20 degrees Celsius or 293 Kelvin. And R is equal to 0.08206 liter atm over mole Kelvin. To solve for the osmotic pressure, we need to find the molarity first. Molarity is equal to mole solute over liter solution. Since the mole solute is not given, we need to find it first by dividing the mass of the solute over its molecular mass. Sucrose or sugar have a molar mass of 342.3 grams per mole. Thus, the mole solute is equal to 340 grams over 342.3 grams per mole, which is equal to 0.99 moles. We can now find the molarity, which is equal to the mole solute of 0.99 moles over the liter solution of 0.24 liters. The answer is 4.13 m. Now that we know the molarity, we can use the formula for osmotic pressure. Osmotic pressure is equal to 1 times 4.13 m times 0.08206 liter atm over mole Kelvin times 293 Kelvin. Therefore, the pressure needed to prevent osmosis is 99.30 atm.
And that concludes our fun chemistry experiment. The whole thing may be at first be hard to grasp, but we hope we helped you in learning it.